Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, today I want to present about our research is energy harvesting from mechanical footstep design and optimization. Okay, I am presenter Encik Muhammad bin Muhammad Saleh. Okay, let's start the introduction. Green technology is the creation and use of product, equipment and systems that help to protect the environment and nature by decreasing or eliminating the negative effect of human activity. Green technology is defined as a system that reduces environmental quality degradation, emit minimal of no greenhouse gases, is safe to use and create a healthier and better environment for all living things. It also conserves energy and natural resource while encouraging the use of renewable resource. It intended to be renewable energy source that utilize favor fossil fuel and harms humans, animals and plants as well as the environment. The quantity of trash and pollutants produced during manufacturing and consumption should be reduced using green technology according to the WIRA. Green technology is the numerous inventive power generating system for flooring application have been built and put into practice. Footstep harvesting is one of the methods to produce renewable energy in a simple way. This is because energy production will occur if human movement touch the footstep platform. There are some researchers have been used piezoelectric to generate electric from mechanical vibration into electricity. The piezo mechanism is the most promising of all transition methods to generate energy for micro device. Other method is using motor generator to produce renewable electricity based on the previous study from Khatri and Gupta. As a result, the concept of employing magnet to generate energy has been around for quite some time. For many years, simple magnets have been utilized to generate electric power due to their magnetic field. They are found inside the core of motor and generator. The magnetic effect is the fundamental principle of power generation. A voltage is induced in the conductor when a conductor is spun in a magnetic field. It's a magnet and engine free energy generator is simple device for generating electricity. In the study focused on 3D modeling and analysis human footstep structure. Besides that, the calculation of energy produced using motor generator have been calculated. There is numerous research about footstep energy according to Talian et al. Has designed a footstep energy harvesting device that uses a DC generator. Their experiment results show that obtain 3 to 5 joule of electrical energy can be generated from each step. However, the pebble top panel displacement is 3 cm, while it's not only uncomfortable for pedestrians but also would not conform to the American with Disability Act. This limit the amount of the vertical height difference between pavement joints. And Bhatia et al. Already showed the design and energy harvesting paver using rack and pinion. They were able to harvest 0.36 watt average power. The replacement of the device top panel varied between 13 and 38 mm, which incurs the same comfort and regulator code issue as the base on the reference given. Furthermore, the overall efficiency, which is less than 20%, is still low. Another company, Deep, came out with the energy harvesting paper called Way Energy that can harvest 0.3 to 0.6 joule of energy per step. If there is a sustainable way to extract lost energy into the ground, this could lead to important milestone in the renewable energy sector. Only foot movement steps that follow the mechanism correctly can produce renewable, safe and environmentally friendly energy. Elizabeth Redmond patent involved two adjacent energy devices placed under a footpath which respond effectively to the applied footstep, increase the output power and communicate wirelessly. Another design proposed using piezo element to generate power from applied force. To the study suggests tiling 3.1% of the total floor area of the building With piezoelectric harvester, we could produce approximately 1.1 megawatt power or energy annually. Walking is an integral part of the daily routine for humans, make it the most commonly activity. A novel power generation system was developed and manufactured in this study, which harness the mechanical energy produced by human footsteps and convert into DC electrical power. The system is particularly suited for crowded public places like railway station, airports, and shopping complex. Okay, design validation. Regarding on the tree design, the researcher took the main assumption in terms of the concept, user size, type of power, result, and durability of the structure that can accommodate the maximum weight set by each design refer table below. Okay, out of the three design compared, the researcher select the third one of the best design and aim to improve it further. The design employed the rack and pinion mechanism to create an energy harvester that convert the mechanical energy from footstep pressure into electrical energy. Okay. For the third, okay, this for first, second, and third. Okay, they use a DC motor and rack and pinion. The energy housing can produce average power output of 3.6 watt over 0.5 second of the step time with a peak power of 12 watt in working condition. Okay, maximum of the power of the top panel is maximum 80 kilo. Okay, for our design, this is a working principle. Okay, for the top panel, the human footstep is step down to the top panel plate and make the rack pinion go down, step down, and then one way clutch engaged with the rotary shaft will be rotating, and then the one rotary shaft will be connecting to the motor DC generator that harvest energy from the rotating. Okay, the footstep energy system work by using the weight of person footstep to compress linear spring, while soft potential energy that is converted into electrical energy through the rotation of shaft connect to the generator, with the rotational speed being increased driven by bevel gear. Okay, the generated power is stored in a battery and convert from DC to AC using an inverter, and the system reset to its original position use one-way clutch and spring. Okay, the block diagram show the illustrate the working principle of the proposed footstep. Okay, the footstep structure model design utilizes a rack and pinion mechanism with 4 compressed spring support in each corner, along with 4 T-shaped housing bearing and the 2 spur gear combined with the shaft at the center. And the 12 volt alternator motor can produce a maximum output of 24 watt at 900 rpm for one motor, and the design used 2 motors to achieve maximum power of 80 watt. A 3D model was created using 3D software, refer the figure below, and material was selected based on design specification shown in table 1. Okay, this design for the footstep for overall. Okay, this is a part by part of the footstep. We show all the part number here, part name here. Okay, this part bomb list. Okay, so all the part bomb list. Okay, material properties, we use three. Actually, we want to analysis of the tabletop of the harvesting structure. Okay, the top panel of the structure is defined of 3 different material, including mild steel, stainless steel, aluminium with varying thickness of 3 mm, 5 mm, and 8 mm. Selecting the appropriate material for manufacturing is complex thus due to the widespread use of footstep product in the manufacturing industry. The total deformation and equivalent formations of top material are predicted using finite element method carried out using static structural analysis. Okay, this is the material properties for the 3 selecting material. Okay, this is a theoretical of power output calculation. Okay, from the power output calculation, 100 kilo of maximum load applied on the top panel of footstep. that generate voltage is 12 volt and the average current produced is 2 ampere with 900 rpm. If maximum rpm used, motor can generate maximum is 24 watt per motor. For this design, only 1 per 3 maximum rpm motor, which is 0.2 second needed for one step on the top panel. From the calculation, we can see for the one motor, we can produce only 8 watt for one motor, and we have 2 motor generator. That's we times 2 with 6 watt for 2 motor. The power of footstep can generate using one DC motor generate is 24 watt maximum. If RPM achieve the maximum, but we only achieve 1 to 3 RPM, so get X watt for per footstep. Result and discussion. Okay, from the 3 material analysis, use the finite element method. Okay, we can see. Okay, the static structural impact study show this critical point of interest to investigate develop stress, resultant strain and deformation within each of the optimized prototype. 1 meter stress is considered in order to get overall idea of the stress along the skateboard structure to calculate safety factor of each of the prototype. Figure 4, 5 and 6 comparison analysis for top panel structure. Okay, from this we can see the comparison analysis. You can see the 1 meters, the highest is the mild steel and stainless steel, but aluminum for the 5 mm. Okay, you can see the factor of safety. Okay, you can see from the previous research is Econ. The minimum is 0.5, then the maximum is 2. You can see the good is the good. You can see here the safety factor is about below 2. You can see aluminium. I think you can see the aluminium is according to the Akin, the factor of safety is crucial consideration in the design, with many outer advocating for the value greater than 1 but less than 8 depending on the material and structure. The top panel for footstep structure design can be made from different material and thickness, but only one material from each group is chosen. The researcher select the 5 mm thickness aluminum alloy 6061 due to its low cost, lightweight and good machinability and easy of fabrication. Material is inexpensive but prone to rusting. A comparison of the weight for different material thickness is provided in table below. The chosen material are optimized to create a mechanical device that is less expensive, more effective and compact. Okay, from this we can see the aluminum is less weight from the others material. Okay, you can see aluminum alloy were compared and the results show that the weight of aluminum alloy is significantly lighter than the others material. Okay, the study then focused on determining the best thickness for the aluminum alloy. Top panel using 1 meters. Replacement and factor of safety have been discussed at the previous section. Okay, for the conclusion, the summarize the implement of finite element method for static analysis in this study have proven to be a successful approach as it closely mimic the examination of an actual product. The initial research objective have been successfully accomplished. Moreover, this cost-effective method solely necessitates the use of computer and minimal additional material. As a result, it's highly likely that most engineers will optimum from this methodology as preliminary step before proceed with the production of physical product. A novel approach to power generation utilizing human footstep energy was proposed, employing the rack and pinion concept. Various operational mechanisms for harnessing energy for the human step were explored, and the resulting experimental data were examined. Initially, CAD software was utilized to design the innovative mechanical footstep device system. Okay, in this study, it found that maximum output of approximately 16 watt per step could be achieved using 2 generators. The top panel, a critical component, underwent analysis using an aluminum alloy